And now for the fun part. Let's make a beautiful color image. So we now go to step number 9. And we scroll down until we see Combine RGB. Let's click on it. And as you can see, a new menu opens. Here are some interesting options. You can see that's the normalization that we're going to use as we mix all the color channels. Leave it on multiply scale. That is the good default. You can see you have the option of none, add, and other options. Go and experiment with these. There's some explanation here, by the way, and it is very useful to experiment with it. For example, if you're doing a mixture of narrowband and some color images and broadband, so you may want to use different options here. Let's leave it at default, that's fine. You can also create your own formula here. We have an LRGB image, so the first tab is fine. If you scroll down, you can see you have mixtures here for narrowband and H-alpha with RGB, and the typical Hubble palette in different forms, and so on. Quite useful. We're leaving it on LRGB 1, and I'm going to start adding the channels. We should now navigate back to our work directory, and that's where the integrated images are. I'm going to select all of them and say open. And now we're greeted again with a assign the used filter. So that is, the filter now has to be associated with a color channel, and in this case it is already correct by default. Just be careful that with some filters it will not work, and then it'll ask you which filter it is, because it's going to say custom there. We just click OK here. And now we go to the left-hand side, and you can see here are all our color or channel mixers. For example, you can see the blue is completely highlighted here, or 100% on blue, and the same for green, luminance, and red. Initially, I just want to see what the RGB image looks like, so I'm going to take the L from the luminance and put it all the way to 0. Let's just take a look on the right-hand side and not overstretch the image too much. So I'm just going to go back here till somewhere in the middle. Let's see what we should select here. I think that 15%, yeah, 3 sigma seems fine. And then let's just do a calculation here. So it just says recalculate. And that's the initial image that we get. It looks a little bit fade, so click here on and enable here saturation, and you'll get an initial feel for the RGB image. Now I would like to finally add the luminance too. So I'm going to go right back here, put the luminance on 100% and do a recalculation. At this stage I'm not worried about the colors, because whatever we save on the left-hand side is saved in linear fashion. What we see on the display, we can stretch whatever we want, but that's not going to be saved that way as long as we save it on the left-hand side. So I'm just going to stretch this to the max now to show you, because now I'm going to look for imperfections in the image, and you can see them straight away, some imperfections. To see even more, let's get the saturation right up to the maximum here, and the threshold, which is right below the lever, I'm going to put that to 0, and now you can look at not a very nice image, but that's not the point. The point is to see what our problems are. You can see there are several problems here. The one is that you can see the background, that is from the stars from our own galaxy. Some call it the Milky Way, I don't want to confuse, but that's our own galaxy here. You can see most of these stars here are not even. You can see the illumination is not even, and we need to correct that as well as the color. So let's do that in the next steps. I'm just going to save it now, just say save, and you're asked again for a name. So, well, we know the object name already. This was NGC292, and it's an LRGB. And then we click on OK and save. And finally, we just leave the menu by just clicking cancel. So let's go to the next part. That is remove light pollution. I'm clicking on it now, and it's going to ask which one do you want. That's of course the most recent one that we worked on. Just click on it and load it. And here we are. So this is interesting because now we have to even the background and take the gradients away. So I'm going to select the background of our own galaxy. Those are the stars that we see. That should all look evenly illuminated. So let's take the lower left first, put an area there, put another one here, and so on. And also here on the top right, I'm going to do one. And don't put too many, put about 6, that's fine. And don't get too close to your object. That's why I made it so bright, so that I can see exactly where the contours are. I'm going to put another one here and just say calculate now. And as you can see, that's already a considerable improvement. And we just have to go on doing this now. So I'm just going to put another area up here on the side. This also looks wrong in the color gradients. And let's put another one right here and there. And I'm going to do another recalculation now. And now this looks a lot better already. You can see there's a red area here. Don't worry about it. It just means that the gradient is very steep. So I can just add a few areas here to tell the software this is all fine. Add a few more here. Be careful not to interfere with any objects that are beautiful night sky objects that would then be recognized wrongly. So again, I just say calculate. And you can see this looks a lot more even and better all the time. I'm going to do one last iteration here. Add a few more here where there's a red area and maybe a few more here. And maybe one more here. And let's put one more here where there's no object and just do another calculation. And you see this looks a lot better already. Maybe some more here in this area, and do one more calculation. Yes, and that actually looks quite nice. That's now you can see that the stars from our own galaxy, they look nice and even throughout the image, and this is quite good. Remember that we have really overstretched it right here. So we have now created a mask actually that's being subtracted from the original image. So what does that mask look like? Click here on the green tab, show corrected image, and you can see it here. That's our corrected model. Click on it again to navigate back. And I'm just going to say OK and save here. Again, this is a linear image that's being saved, and you can see here new labels have been added. So that's the light pollution correction, and also the background correction has been added to our designation here. And we save it always as a FITS file at this stage. And that ends that part of the menu. We now have to find the white balance. And in order to do that, we go to the Calibrate Star Colors tab. We click on it, and it says, do you want to calibrate the star colors in the current image in the image viewer? Yes, in this case, that's exactly what I want to do. So that's what it's going to do now. And the first thing that we are asked here is, please make at least one area in that represents the night sky as we see it. Again, those are the stars from our own galaxy. The background that we've just actually corrected for gradients. So I'm going to do that. I'm going to put a large area here in the lower left, and I'm going to put a large area here. And be careful you don't get too close to the object. That should be fine. And then I just say calculate. Let's do a calculation with that. And now watch how the color of our object changes, also the histogram. I'm just going to reduce the stretch here a bit because it's really about colors now. There, that looks a lot better. Now we can see the colors quite well. So as you can see, the image indeed has changed in color, so some correction has been going on. Let me explain now how all that works. Let's first talk about stars in general. A star mainly consists of very hot hydrogen and helium. The temperature is so high that in the core of the star, energy is produced via nuclear fusion. This results in a tremendous outward pressure. At the same time, the star is also very massive, and gravity is causing an inward pressure. Nuclear fusion pressure and gravitational pressure are in balance for most of the star's life. It's a very delicate balance. This balance is called hydrostatic equilibrium. The majority of stars that you see in the night sky are actually in hydrostatic equilibrium, and they shine in different colors. They radiate similar to what we call black bodies. Some, like our Sun, at a temperature of around 5,800 Kelvin, which corresponds to the yellowish, greenish look that we have. By the way, this coincides with the maximum sensitivity of our eye. That is no surprise. That's the way nature invented us. Then there are the brighter and hotter stars that look a lot more bluish, and actually the majority of the stars are cooler and they look a lot more reddish. So what are these diagrams that we have there in the middle? These two diagrams are called color-color diagrams. They may seem a little bit unfamiliar at first. We are plotting the light or flux that goes through our green and blue filters, and also the red filter of course, onto our camera sensor. The color index, that is the designation here on the horizontal axis, for example also on the vertical axis, let's look at that, called G minus R, of a star is the difference between the magnitude of a star with one filter and the magnitude of the same star with another filter. So it's the same star. Any filters can be used to measure color indices. The result very much depends on the type of filters and the spectral characteristics of these filters. So the plot will vary with different filters. What you see here is a logarithmic plot of the color filter flux quantities. So let's look at the horizontal axis here called G minus R. The more you move to the right, the redder and cooler the star gets. And the more we move to the left, the hotter the star gets. Negative numbers mean higher temperatures. This is because the larger the magnitude of a star, the lower the number. The logarithmic plot actually corresponds to the ratio of the filter magnitudes that you have here. There's another advantage of drawing a color-color diagram. Because we are measuring flux ratio of different filters, the result is independent of the distance to the star. There's also a relationship between the color index, for example G minus R, to the temperature of a star. How does that work? Well, the origin here corresponds to a black body temperature of around 10,000 Kelvin. This is our white point. The color index of going to about minus 0.25 would correspond to about 15,000 Kelvin, and a color index of, for example, of our Sun is 0.656. And that corresponds to about 5,700, 5,800 Kelvin. By the way, the axis plot here depends very much on the type of filters that you are using. For example, even if you were to redo this whole image only with RGB, and I encourage you to try that without the luminance, you will see that the plot will extend a lot further, all the way maybe to 0.5, and as hot as minus 0.5. And so it depends very much on the filters and also the combination of filters that you're using. So why did the color actually change when the graphs were first plotted? This is because the color indices were matched to the black body temperature, and every temperature corresponds to a certain color. Within the range of this plot, we can expect that about 80% or more of the stars should be in the red quadrant here, and the rest of the stars in the blue quadrant. This is because red stars live much longer than blue stars. On the other hand, the blue stars are much brighter than the red stars. By the way, this plot will also work for a single-shot color camera. It will look different as it really depends on the filters and spectral responses of the color cameras. It will not work for narrowband filters as these are emission filters. So now that you know the background, let's have a look and see how we can make some use of this. As I mentioned before, about 80% of the stars should be in the cooler red region. So let's navigate to the left-hand side And you can see here are some different sliders that you can use. The first one you come across here is the star rejection kappa. Those are the orange stars that have been rejected, the so-called outliers. There's no need to change this here because we only have very few outliers. If you have more outliers, you may want to adjust the slider. As next, let's look at the next tab. It's called the blue to red ratio. So do we want to weight this a bit more red? Of course we do, because we want to shift the stars more into the red. So I'm going to do that here, and I'm going to click, and let's make it about 0.05 and do another recalculation. Then also watch how the histogram and in fact the color of our object changes. Let's scroll up again and click on calculate. And you can see there's already a correction in our image, and you can see it's become a lot more reddish. In fact, this looks quite good already. By the way, you can also change the gradient here if you wish to, the temperature slope if you want to adjust this more. I'm just going to demonstrate to you very quickly how to do it, although this is already quite a good fit. So let's do that very quickly. Let's scroll down and let's adjust the slope. We could decrease the slope a little bit, couldn't we? So you go here to the upper diagram, you can see that's the blue minus green versus green minus red. And let's just adjust the slope here. I'm going to adjust it maybe somewhere around, 0.65 is okay. And then because the filters are correlated, I want to also get a better fit down here. So I'm going to the other one. You see here the slope says the slope of 2. That's because you have B minus R here. Blue minus red corresponds to a different slope. So I'm just going to click on it and also move that down a bit. And that seems about right. And I'm just going to recalculate it and watch the fit now. And you can see here the black body model, that's the green, the current line, has shifted indeed. And it seems a much better fit now. And that a little bit whitish grayish line was the initial one. And I think that's quite good. So I encourage you to experiment a lot with these, but be careful with the way you use these sliders, because the sensitivity may affect the image quite a lot. So I'm just going to say OK and save it, and we're happy with this. The designation here now, the label is now corrected star color, and that's fine. And we go and save it. Now that we've done it, the image looks a lot more like it is supposed to. So I'm just going to bring the saturation down again quite a bit and put the threshold up quite a bit here on the right hand side, because now we're going to do the final adjustments. And I encourage you also in between to take a cup of tea or a cup of coffee and then come back and to re-look at your image, because sometimes our eyes adjust too much to a saturated image and then it doesn't look really good. So let's talk a little bit about these sliders here on the right hand side. So you can see you can adjust the black point, the white point, and so on, and you can find all the different instruction windows over here. Anyway, all we need to do here really is to fine-tune it. We could possibly start by seeing what is the correct stretch. So let's de-stretch it a little bit and see what the result is like. And you can see that looks quite good already. Again, this depends on your personal taste. There's one very good thing that I would like to point out about the sliders here. You can change the sensitivity. If you ever click on the left-hand side, you can see this is changed between 1 and 2. That's a very coarse slider, so be careful with that. And if you want a very fine adjustment, you click all the way on the right-hand side and you can see it's between 3 and 4, and that'll adjust it very fine. Most of the times, I leave it at default here between 1 and 3. One thing we may want to change here is the contrast. You can see it's on 0, so I'm just going to change it just a tiny bit and maybe go up a little bit more, go to about 0.2, and that's already a good contrast. So before I sharpen it, I would just like to crop the image. So let's go quickly into the crop menu, batch modify. Do you want to do it on the current one? Yes, I do. Let's just drag our mouse along. I'm just going to take an arbitrary window here and say we want to crop it like this at the moment. So I just say crop OK. And please provide a file type name, that's fine. And now it is saved. So in order to reload that, we scroll all the way down and you can see here's our modified picture. just load it again. And there it is. You can see it's cropped. And now I can do the final adjustment that I want to do is just to sharpen it a bit. Now be careful with the sharpening, because if you sharpen galaxies, you may over sharpen the core, and that leads to artifacts. That's why there's a protection here too. So you need to really play around with the sensitivity of the protection and the sharpness. I'm going to sharpen it quite a lot here, and this takes a bit of time. And then when the sharpening process is completed, we can now save the image. This time we're going to save it on the right-hand side. Be sure that the stretch is enabled, which is by default, and just click on Save. And now we're prompted here with a name. You can see it has also the label here at the end, ST, which means stretched. So we just say OK. And now we don't save it as a fits. We're going to save it as an image that everyone sees. 16-bit TIFF is a very good idea. The color space, leave it as default. That's the best color space to use. And then we save it as 16-bit and just click OK. And that brings us to the end of the tutorial. I hope you enjoyed it. Enjoy Astro Pixel Processor and enjoy the beautiful skies with iTelescope. Thank you so much.